When we have one function divided by another and we want to take the derivative of that, unfortunately is not equal to the derivative of the top divided by the derivative of the bottom. It's actually far more complicated than that, but there's a nice rule for it. It's called the quotient rule, and here it is. And don't worry, there's a simple way of remembering this, but in its initial form here we have d by dx of f of x divided by g of x is g of x times f prime of x minus f of x times g prime of x all over g of x squared. There are a lot of x's in that version, so here's a slightly simplified version. A over b quantity prime is equal to ba prime minus ab prime all over b squared. And the way you remember this is to use a little jingle. I warn you, it is silly, but it works. Lo-dee-hi minus hi-dee-low over the square and away we go. This is how you set the quotient rule to memory. Right, the low is the function in the denominator, and the high is the numerator. So lo-dee-hi minus hi-dee-low over the square, and away we go. There are other versions of this jingle. For instance, some learn it as ho-dee-hi minus hi-dee-ho all over ho-ho. Okay, so pick your poison, but you remember it using some kind of jingle usually. Otherwise, it's just a long string of symbols, and it's easy to get those mixed up. And if you get them mixed up, your quotient rule is wrong, and that's deeply problematic. Let's try it on an example. Here we have f of x equals x over quantity x plus 1, and we want to know what the derivative is. So this is a perfect candidate for the quotient rule. Our low in this example is the x plus 1, so we'll call that low, and the x is the high. Okay, so then we'll just jump right in. So we'll say f prime of x is okay. We'll use the jingle here. Lo-dee-hi, which means I just write the low. Lo-dee-hi. D-hi, well, the derivative of x is just 1. Let's actually just do it out here. X prime, all right, minus high x d-low, x plus 1 prime, all over, or I guess we'll say over the square and away we go. So we're just going to keep that denominator as it is and square it. So that's the setup to the quotient rule. Usually you would just go ahead and evaluate the derivatives rather than writing the prime out, but this is just to demonstrate how it works the first time. X plus 1, okay, x prime is just 1, so we have x plus 1 minus x times x plus 1 prime is simply 1 again. So x plus 1 minus x all over x plus 1 quantity squared. And then of course these x's cancel out and we end up with 1 over x plus 1 quantity squared. There is our derivative. Let's try another example. Here we have d by dx of e to the negative x. So that's the derivative of e to the negative x. And we'll eventually learn something called the chain rule, which will be an easier way to evaluate this. But for now, let's rewrite this as, okay, we want d by dx of, let's say, 1 over e to the x. And now we can use our quotient rule on it. Okay, so we have our low and our high. Low, and the low is e to the x, and our high will just be 1. Okay, using the jingle, we have lo-dee-hi, so low is simply e to the x, d-hi. Well, the derivative of 1 is 0, all right, minus high, 1. D-low, well, the derivative of e to the x is simply e to the x. Over the square and away we go. So that'll be e to the x quantity squared. All right, cleaning this up a little bit here. Well, e to the x times 0 is 0. So we are essentially looking at minus e to the x over e to the 2x. Well, we get some cancellation there, leaving us with negative 1 over e to the x. So you could leave the derivative like that. You could also write it as negative e to the negative x. Okay, so quotient rule is super useful in many different contexts, and it will be one of the main tools moving forward in calculus.